Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in the previous modules we have already discussed the very important concept of capacitor. Then we have discussed about the expression of energy stored in parallel plate capacitor, right? Now students, in this particular module we'll be discussing about another important concept related to capacitor, that is capacitors connected in series, right? Now in this particular module we'll be finding out the expression for effective capacitance of capacitors connected in series. Right? Now students, capacitors are said to be connected in series when they are connected one after another in the form of a chain, right? So let's say we are having three capacitors right now. Let's say first capacitor, second capacitor, and let's say this third capacitor. It is connected to ground, then connected to key, and then connected to the battery, which is having two terminals, negative and positive. And this is how circuit looks like when three capacitors are connected with the battery, and these three capacitors are connected in series, right? Now let's say these three capacitors are having capacity C1, C2 and C3. So first one having capacity C1, second one having capacity C2, third one having capacity C3, and these capacitors are made up of insulated metallic plates AB, CD and EF, right? So first capacitor C1 is made up of plates A and B, second capacitor C2 is made up of plates C and D, and third capacitor C3 is made up of plates E and F, right? Now see this diagram carefully. Now see plate A and the positive terminal. So I can say plate A is connected to the positive terminal of the battery, right, which is having EMF E, and it is having potential difference capital V, which is developed across this particular circuit, right? Then plate B is connected to plate C, then plate D is connected to plate E, and plate F is connected to the negative terminal of the battery through plug key K, right? Now let us move further. Now when this key K is closed, when I'll be closing this particular key, what will happen? Because of the battery, charge plus Q will be developed on plate A of capacitor C1, right? Or I can say plate A is positively charged with charge plus Q, right? And because of this charge plus Q, induction will take place, or rather electrostatic induction will take place. And because of that electrostatic induction, this plate B will acquire charge minus Q, right? So see the diagram carefully. Plate A is having charge plus Q and plate B is having charge minus Q, or rather it is acquiring charge minus Q because of induction. Then again because of induction, plate C will acquire charge plus Q and plate D will acquire charge minus Q, and so on. Plate E will acquire charge plus Q and F will acquire charge minus Q, right? Now let us move further. Now in case of capacitors connected in series, the value of charge across each capacitor is same, but the value of potential difference across each capacitor will be different, right? So there are three capacitors, each one of them is having capacity C1, C2 and C3. So let V1, V2, V3 be the potential difference across three capacitors, right? So in this particular case I can write the total potential difference V, it is equal to V1 plus V2 plus V3, right? Now students, we also know basic equation of capacitance. What is the basic formula? C is equal to Q by V, right, where Q is the charge and V is the potential difference, and from this I can write down the expression for V as Q upon C, right? Now let us move further. Now using this expression of V is equal to Q by C, we'll find out values of V1, V2, V3 and V, right? So I can write V1 as Q upon C1. Why Q upon C1? Why not Q1 upon C1? Because in this particular case the value of charge is constant, right? Or I can say charge on each capacitor is constant. So again I can write V2 as Q upon C2. Similarly, V3 will be equal to Q upon C3, and last V can be written as Q upon Cs. Now I'll be putting all these values of V1, V2, V3 and V in the first equation that we are having, right? So what will I get? I'll get Q upon Cs. It is equal to Q upon C1 plus Q upon C2 plus Q upon C3, right? So from this particular expression I can take out Q as common. So what will I get? Q upon Cs, it is equal to Q in bracket 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? So I can cancel out Q. So what will I get? I'll get 1 upon Cs, it is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. And students, this is nothing but the expression for effective capacitance for three capacitors connected in series. So what is the formula? For three capacitors connected in series, the formula is 1 upon Cs, it is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now let's move further. Now let's say, students, if n capacitors are connected, right? Let's say n capacitors are having capacity C1, C2, C3 and Cn. And if all these capacitors are connected in series, then the effective capacity is given by the formula 1 upon Cs, it is equal to 1 upon C1 plus 1 upon C2, and this will go till 1 upon Cn. And this is nothing but the effective capacitance of n capacitors connected in series. So students, in this particular module, we have learned that when capacitors are connected in series, they are connected in the form of a chain, right? In case of series combination, the value of charge across each capacitor is same, but the value of potential difference across each capacitor is different, right? So for three capacitors, we are having formula 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. And similarly, we have also written the formula for n capacitors. So students, that's it for this particular module. I'll see you in the next module. Till then, keep learning.